Yeah, hi, CB Chakravarti.
Hi, ma'am.
So, can you tell me about yourself? How are you, first of all?
Yeah, I am fine, ma'am. How are you, ma'am?
Yeah, I'm doing good. Okay, just give me 2 minutes. I can go through your resume. Meanwhile, just introduce about yourself.
Yeah, sure, ma'am. First of all, thank you for this opportunity, and I was too excited. And myself, I am CB Chakravarti, and I completed my Bachelor's of Engineering in Electronics and Communication. And and I am a recent graduate, 2024 passed out student, and I am a fresher. And my passion towards VLSI starts when I was third year, and from that time onwards, I'm start preparing in digital electronics and Verilog. But definitely, VLSI is far more than that. So after my graduation, I started doing my internship. It is a 6 month internship, and I learned about digital electronics and Verilog deeply, and I learned about system Verilog, UVM concepts, and some projects using FSM, and I have learned about protocols, some basic protocols, AMBA protocols like AHP, APP, and AXI, and then some serial communication protocols like UART and I2C. And I have some confidence that I can perform in design verification. My internship provide such knowledge to me, and yeah, I was interested towards design verification and VLSI.
Okay, okay, fine. So, what are the projects you have worked till now, other than protocols?
Yeah, I have worked in 4 port calculator and 1x3 router.
Router project. Okay, fine. So from router project, have you done it in RTL design or only verification?
No, no, I did only verification. Actually, it is not at fully completed. Right now, I have an idea on IX3 router, and I have that design concepts, and I have some idea on that.
Okay, fine. Okay. So coming to the protocols, can you explain the difference between YORT and I2C?
Okay, actually, UART is a asynchronous, which have no clock, and I2C is synchronous, and UART is actually the similarities between these two are serial protocols, but uh, I2C is intra protocol, which is used inside a device, but UART is inter protocol, which is used outside between two devices, which is communication between two devices, and the speed may vary. UART comes under some BPS, that is bits per second, to some kilobytes per second, and I2C can have to some Mbps speed.
Okay. So how you have designed the I2C
Okay,
or
when it comes to I2C, it is actually I designed some basic model using SD and SEL line. And the basic concept is I took that frame format, where to start and what is that data and how to use that acknowledgement. I took that frame format, and then I started realizing that okay, when clock is high and when our STA is high to low, then it will start like that. I understand that concept, and I started designing using Verilog language, and I verified it using SystemVerilog. And I2C, I designed it using that STA line, and I used FSM concept in that, like when to start. Because when using FSM, we can correctly point that in which state it should work. Right, in right state it will work. So we use FSM. So and using that clock concept, I using that STA port and SCL lines, and using that frame format, I designed that I2C.
okay. So you verified in system Verilog, right? So can
Yeah.
you explain a one scenario in system Verilog, like how you have written the test bench or any test case for I2C to verify SD and SCL output data?
Okay. When it comes to I2C, it take master or slave. what I took is I took a slave and I give a scenario so that I check whether it will uh, serially communicate properly or not. So I first of all, what I decided is first either we take master or slave. So when coming to that, I took slave and I passed the input test scenario by building that SV architecture, generator block, driver block, and monitor and scoreboard. And using transaction block, I started to feed some test scenarios. So how it is like I act as master because I feed that input and I check okay it is working properly on that or not. So I provide some I provide some inputs. So I checked whether it works correctly or not. And yeah, at first time when I feed that input, it is difficult for me. Then after some changes, yeah, I got it.
Okay, fine. So how would you rate yourself in SystemVerilog and UVM?
Okay, when it comes to system Verilog, I will rate around 8 out of 10. And UVM is little bit lower because UVM is it's like a vast topic. There are a lot of libraries, and I am not that much deep into that coding concepts. And in system Verilog, I'm okay with that. I will rate around 8 by 10, and UVM around 7 out of.
Okay, fine. Okay. So in SystemVerilog, can you explain how did you verify a test sequence in UVM, and what is the difference between UVM test bench and SystemVerilog test bench?
Okay, the architecture itself slightly differs because in FV architecture, it will comes like generator block, driver block, and then we use monitor and scoreboard. But when it comes to UVM, we pass the sequence in the top layer in the test, and inside we have sequencer and driver, monitor, and scoreboard. And mainly in UVM, we give importance to agent, where in SP we just form that components, and in environment we do our functions. But in when it comes to UVM, we give importance to agent, and there are a lot of advantages while using UVM. That is, we can configure the components, and we can use agents like passive and active. There are many we can use uh, elaborately when we come into UVM than system Verilog.
Okay.
And the modules uh, that are reusable in when it comes to UVM, there is a lot of chance for reusability. But when it comes to system Verilog, we always need to create from scratch. That is what I found using these two.
Okay, fine. Okay. So first we'll start with the SystemVerilog.
Yeah,
Can you share your screen?
yeah, sure. Ma'am. Yeah, is it visible, ma'am?
Yeah. You can open Notepad. Okay, fine. So in SystemVerilog, can you tell me what is the concept of randomization and constraints?
Okay, when it comes to randomization and constraints, uh, always we going to feed some input, right? So if we have many scenarios, how can we feed one by one? It will take a lot of time. So by using randomization concept, it will randomize the inputs. It will give different scenarios so that we can check every corner cases. And constraint means for every inputs, we limit our that input access from which range to which range, and what should be our input is like that. So to restrict that input, we use constraints.
To restrict the input, we use constraints.
Restrict means
Okay.
to limit that input, uh, to set that range for our benefits.
Okay. That means we can able to control number of signal input data or whatever particular data we want to create. So we can randomize accordingly. So based on the requirements specification. Okay. So my question is, just create a class, a transaction
Okay.
class with ID
Okay.
and value properties. In a transaction class, we must
Okay.
have ID and value properties. You need to randomize 10 transaction objects.
Okay.
Okay, so each ID is unique.
Okay then.
That means you need to generate a unique number of values to ID, not repeated values. And
Okay.
another property value is there, right? So for that, you need to randomize between 0 to 100 number of values.
0 to 100, right?
Yes.
And what is the condition for ID? I think I forgot about it.
For ID, it should be
It should,
unique. Value
okay.
should be unique.
It should produce 10 inputs with unique values, right?
Yes.
Okay. Okay. Myself first randomize first, and since it should provide unique for 10 uniquely 10 inputs, I will use rand C so that it will not repeat. And then for value, I just use rand. So we can use unique constraint also, because when we use unique constraint, it will produce unique values. But when it comes to two inputs together, we can use either we know, else we no need to use that.
Okay. Just write the code snippet and we can discuss.
Just give me a second.
Yeah, you can take your time.
I need to write module block or just this constraint is enough?
Constraints are enough. Okay. So why did you write for loop for ID? Is it required?
No, actually, I think for loop is not required, but for you told that to repeat 10 times, no? So for that, I use that for loop. Else, we can provide simply some, if we want to provide some unique values, 10 values mean we just use our inline constraint like ID inline. We can provide some 10 values randomly.
Okay. Okay, fine. So next
Okay,
question.
assurance.
Like weighted distribution, right? In randomization.
Yeah,
So in weighted distribution, can you explain what are the different types we have?
okay, actually, I need to go through it once because I lack in that.
Okay. Okay, fine. So what is the difference between inheritance and polymorphism?
Okay, when it comes to inheritance, uh, it is like hierarchy. We have parent class and we create a child class. So our child class can access that parent class properties. It is called as inheritance. And when it comes to polymorphism, if we have a method, we can use that method differently by passing our arguments. We can pass our arguments differently, and we can make that method use in different scenarios. This is what that is polymorphism, simply uh, using a single method in many forms.
Okay. So can you write a code snippet for inheritance and polymorphism? So how the base class are deriving from parent class? So parent
Okay.
class and three base classes, the difference between polymorphism and inheritance.
You told me to create three classes, right?
Yes.
Mm. When it comes to inheritance, this is parent class which I was created, and the thing is in module, if we create an object, if we create an object for the child one class, we can access the parent class properties directly. This is called as a higher inheritance. That is, so when it comes to polymorphism, if we use when it comes to polymorphism, if we uh, see here we pass arguments in the parent class, and we can change this. We can pass differently. This one method can be passed differently when it comes to module. This is polymorphism. That is one method into many forms. I have created one method. This is construct, and if I simply create some other functions like if I create like this, so this is basic add function. So we can change the way of arguments we pass in this one method using this one method that is called as polymorphism.
Okay. So how inheritance is working here?
Okay, let me complete.
Because you have taken one to many from parent to child one, child two, child three.
Okay,
So how you can use same program to inheritance and polymorphism?
no, actually for polymorphism I have like slightly changed, like I changed this into an addition function. But when it comes to inheritance, I just give uh, one value as I, and I just accessed this variable using this child class instance. Child one instance. I just created an object using this child class, and just I accessed that class parameter, parent class parameter here.
Okay.
Yeah, yes, ma'am.
Okay. One function is for polymorphism, one function is for inheritance. Huh?
Yeah, actually, I can do separate code, but using this same code, I just explained, ma'am. Here there are many corrections, but for explanation, I just made this.
Okay. Okay, fine. Next question. I want to do addition operation for A and B. Okay. With the 3-bit size. A is equal to 3-bit size and B also 3-bit size. So for output, I'm going to create with a 2-bit size memory to store the output.
Okay, come again, ma'am.
Output declared as a 2-bit size.
Okay,
But when
but
I'm trying to store
uh,
the input, the output operation into the out, the storage is not sufficient. The memory is not sufficient. Okay.
yeah, yes,
So
ma'am.
I want to change the array size 2-bit size to 5-bit. I want to resize the array.
Okay,
So
okay.
here, which type of array you will be using and how to write the program?
Yeah, we can use dynamic array here. Because while using dynamic array, we can change our size of that array.
Okay, can you write the snippet?
Yeah. Can I pass the input or just declare and explain is enough?
Sorry, I have muted. You can pass the input also.
Okay, wait a second. I just put. Sorry, ma'am. I think it will be little bit confused. I think.
Okay. Just create normally the out
Mm.
as a 2-bit size, 1 down to 0, bit out, bit 1 down to 0 out. After doing addition operation, if it is not sufficient, then you can use out is equal to new of whatever the value you want to resize. That value you can put out is equal to new of. Initially, you need to um, create with a 2-bit size, then 2-bit need to resize with 4.
I think I need to go through this topic. This dynamic array. I can remember that we can use new here, but I don't know how to implement in this place.
Okay, just new of 4. Okay, fine. 2-bit in the sense 1 down to 0 you need to put. And also,
Uh,
while you are assigning the value, is that way of assigning the array value to the locations 2 down to 0? 2 down to 0 means 3-bit. In
Sorry,
each
ma'am.
bit,
What?
how much is that way of allocating the value to A?
Wait.
Okay, so somewhere you're putting left side and right side for variable. So what is the difference if you declare left side or right side? Like what is the difference between packed or unpacked?
Okay. When it comes to packed, it shares same memory location. But when it comes to unpacked, it denotes that we have different memory locations. That is what that memory allocation is different for packed and unpacked. For unpacked, we have separate location.
Okay, okay. You have worked on APB protocol in system Verilog, right? So
Hmm.
whenever you are connecting the design with the test bench, so how you are connecting in system Verilog the design with the test bench?
Okay. You are asking to APB, right?
Yeah.
Okay. When it comes to APB, there are two phases. One is setup phase and one is access phase. So using that two phases, I designed using an FSM. And when it comes to design, as usual, I used to create that test bench system Verilog test bench architecture. And since APB is for parallel communication, but it is low speed and for parallel communication, I pass the data parallelly and I checked whether it transmits the transaction is happening properly or not. One second,
Okay.
ma'am, I think. Uh,
Can you draw the test bench architecture?
yeah, sure.
Interfacing the design with test bench.
You mean that DUT to testbench, right?
Yes.
Okay. In our testbench architecture, we have four components. When it comes to system Verilog, it is here generator, and here driver, and monitor, and so we can do transaction between these two will happen through a mailbox. And between monitor and scoreboard also we use mailbox. This is environment. Basically, in system Verilog test bench for this, I particularly did not give that much importance to agent. I just give directly that environment. So here DUT and the connection between this test bench and DUT is made through interface. Yes, ma'am.
What is the difference between interface and virtual interface in system Verilog?
Okay, actually, when it comes to virtual interface, it is dynamic in nature. So our class like generator, driver, and monitor scoreboard components are built through class using OOPS concept. So when it comes to class, it is dynamic in nature, and virtual our DUT it is static in nature. So our normal physical interface is static in nature. So connection between dynamic that is dynamic in nature and static in nature, connection between these two is not possible. So we use virtual interface to connect these components which are built using class.
Okay.
And one more important thing is we can use virtual interface only after creating a physical interface. Only through physical interface we can create virtual interface.
Okay. Can you write the code for that? How we create the physical interface and how the instance was created with virtual interface?
Yeah. Okay. Let's consider if we are doing some half order like that.
You can try with APB.
Okay.
Just basic signals enough. Clock, reset, P address, P data, P slave error.
Let's consider this for just for an example. So for interface we can also use clocking blocks and more ports and all. But just for explanation, I just avoid that.
Okay.
Okay. When it comes to class, what we usually do is we use virtual keyword, and which we are going to use is interface, and for that we are going to provide a name for virtual interface. So that is, then we can use mailbox and all. Where we use actual interface means when it comes to final test block, test to DUT, where it's going to communicate with final DUT, in that place we use our actual physical interface in our final test bench flow.
Okay.
So
In test,
basically,
you are
virtual interface
connecting
is
with
used by
SSID.
this using this virtual keyword. This is what.
Okay. So in interface, you have written the mode port and clocking block for driver and monitor. So how you are going to connect using the virtual interface to the clocking block of signals? How do you
Okay.
connect the signals of clocking block using virtual?
Okay. For example, by having clocking block like, let's consider like this. I don't know what here exactly comes, but how we call means we call using that location like virtual interface dot which mode port we are using like that. We point that particular location.
Where, okay, you took generator class. Is that generator class or did you took normally
No, no, no. I
class?
just explained.
Okay, fine. So if basically in generator class we don't use any virtual interface. We don't have any connection of virtual interface in generator. In generator we have the transaction data. Whatever you have written before, can you write again that interface dot modport dot clocking block? Yeah. So to this, you are sending transaction data. So VIN, if the name is there, right? The virtual interface name. So to that, you need to pass the any data p address. Suppose you are taking p address dot p address. Clocking block name you need to write. Oh, okay. You have written a reverse. Actually, first you need to write virtual interface dot modport dot clocking block name dot then yeah, modport means modport instance dot clocking block instance dot particular signal. Suppose p address. Yeah. So this is what interface data. To this data, you need to pass transaction data. Transaction data is a randomized data. Whatever you are randomizing from generator class, tr.p data. For transaction, you need to create transaction class. For transaction class, you can create an instance dot d data. This data you are passing to the virtual interface from driver to DUT. If you consider driver to DUT.
Mhm.
If you consider monitor DUT to monitor, then
Yeah,
reverse. Virtual
yeah, and
interface
that,
is
yeah.
getting
I
to
can
the
understand because,
section data.
uh, because driver and monitor only directly that communicate with the DUT.
Mm.
Generator will communicate with driver alone. So we use mailbox and similar for a scoreboard also that same. It will communicate only with the monitor. So it will also use only mailbox. But when it comes to driver and monitor, we use virtual interface.
Virtual interface and mailbox, two connections will be there.
Yes.
While you are creating the class constructor, you need to pass two arguments in the function. Okay, fine. Okay. Next question. In Verilog HDL, can you tell me what are the sequential execution statements and parallel execution statements blocks?
Okay. When it comes to sequential and parallel, inside parallel we use fork and join. Uh, but when it comes to sequential, we use begin and end. And inside that we can use in sequential we can use blocking and non-blocking. And in that both blocking and non-blocking we can use our begin and end that statements.
Okay. Then what are the parallel execution blocks?
Fork and join.
Fork and join. Okay. Okay. So can you write a small snippet? I will give you the question. X is equal to
Yeah.
10. Y is
Yes.
equal to 5. Z is equal to 20. Okay. Within the block, begin and begin.
Okay. I need to use begin and block, right?
Yes.
Okay.
X is equal to Y plus Z at
Okay.
5 simulation time. First, starting itself for X. Hash 5X. And next, to simulation time, y is equal to z minus x.
Mm.
At for simulation time, z is equal to x plus 10. Next, at 10 simulation time,
Mm.
x is equal to z minus y. So here consider same example with the blocking and non-blocking. Then what is the output for blocking case and what is the output for non-blocking case?
Okay.
You just write directly output, no need to take separate blocks again.
Okay.
Fine. Okay, leave it.
At first, I will consider this blocking at 5 time period. I will get the output as 55. Since it is blocking, it blocks one statement before execute the before the previous statement is not executed. It will not allow the next statements to execute. So when it comes to non-blocking, This is what I got.
Is that correct?
Okay. For blocking, it is okay. I'm done with it. But when it comes to non-blocking, this timing is okay. But for output alone, there is a little bit confusion. What does it means? It will update that RHS side, and first of all, it will update that RHS side. Then only it will be assigned to that LHS. That is what non-blocking is. So that part alone, I was a little bit confused. Uh,
In blocking assignment, first output is 25, but in non-blocking assignment, y out is equal to 30 for first statement.
yeah, because uh, this Y is executing before that moment. This second statement, that is hashtag 2, Y is
Okay.
equal to Z minus X. So I got that output 10. So after that, this Z statement is executing secondly, and then
So
this
here you are telling first, second statement will execute, then fourth will execute, then fifth will execute. Based on second one, fifth is dependent.
that is what that's what I told starting on that part alone I
But
was
okay, fine. But why the fifth time delay statement will be dependent on two? Because begin means a serial execution statement. All statements execute sequentially, whether it's a non-blocking or blocking. Okay.
uh,
So next two statements that mean 2, 4, 10. These statements will be dependent on 5. Okay. But why the 2 will be dependent, 5 will be dependent on 2 here?
okay, okay. Uh, what I thought is I just confused with fork join and this non-blocking, I think. So
Okay.
if that is right, then the output will be same, but the time will be differ, I think. The same output will come to non-blocking and the timing alone will differ.
Okay. Another thing is for blocking and non-blocking, blocking will retain its previous value, non-blocking will not retain previous value. Whatever the initial declaration value is there, it will follow same value to entire execution. Okay, then how the output will be same?
Okay, okay. Okay, then it will be based on that starting value, which you give like x is equal to 10, y is equal to, it will consider that alone. Without any
So
updation, it
that's
will give. Okay,
okay. Okay, just check with this topic once. Okay, so
okay,
difference between blocking, non-blocking, fork join, and how the execution and what are the delays. You need to check with the delays also. Regular delay, inertial, intra-assignment delay, and intra-assignment delay.
interesting.
For non-blocking, we don't use delays here. LHS
We
side
use
or H.
inter assignment, I think.
So check with the delays also. Okay. And next, what is the difference between dollar display, dollar monitor, dollar strobe, and dollar write?
Okay, dollar display, dollar monitor will monitors every changes in the statement. If change occurred in that statement, then it will be printed in that monitor. So that is what dollar monitor. It keep on monitoring what changes happening like that. When it comes to dollar display, it will display only at that particular instance where we use that statement, where we use that dollar display, that alone will print when the time comes. And dollar write is uh, similar to dollar display, but the difference is dollar display will print next lines. Dollar write will print horizontally, that is side by side. And when it comes to dollar stroke, it will print the final answer. That is the final statement alone.
Okay, okay, fine. So in SystemVerilog, we use the coverage, right?
Yes, ma'am.
So why do we use the coverage?
Okay, when we design, when there is a DUT, and if we have a input, there may be plenty of test scenarios, test cases. So we can't check line by line whether it is covered or not, whether this input is covered or not, like that. So to check that coverage, whether all the test scenarios are covered, whether our bins are hit properly, for that purpose, we use coverage. Whether our design is completely covered or not, whether our functionality is completely tested with that, with all the possible test scenarios or not. For that purpose, we use coverage.
Okay. So in coverage, what is the difference between illegal bins and ignore bins?
Okay, when it comes to illegal and ignore bins, in while writing that coverage using illegal bins, we mention some bins like one, two, like that. If that bin occurs, then it is considered as illegal. In some compiler, it will provide that these bins are illegal, but in some compilers, it will provide error. That is the problem with that. When it comes to ignore bits, it just ignores that bit. Instead of providing that error and it noting it as illegal, it just ignores that bit. It will avoid that. Which are the bins mentioned in that ignore bin?
Okay. Okay. And coming to the constraints, so what is mean by soft constraint? Why do we use the soft constraint?
Okay. For example, if let me explain, because by telling I can't. Let us consider this. Okay. If we have a condition like this, that is range is equal our A. If there is a input A and it should be print below 20, and while declaring our object while randomizing, okay, if we mention like this, here we can note that there is a conflict between these two. That is, A should be uh, greater than 20 at the same time. Uh, yeah, A should be greater than 20 at the same time A should be less than 20. So in this case, there will be a conflict because it can't print like that. So to avoid that, we use soft keyword here. So by using soft keyword, it will consider this randomized or object not randomized. This constraint it will be considered.
Okay. Are you writing same constraint within a same class?
No, no, no. Here there will be different.
Okay, fine. So what is mean by with here?
Okay, we use with when we use
What type of
inline
constraint it is?
inline constraint.
Okay, okay, fine. In SystemVerilog, so while we are writing the assertions, so how do we like validate some behavior by using the assertions?
Okay, when it comes to assertions, we have two types of assertion. Uh, one is immediate assertion, and one is concurrent typing. And for immediate assertion, we just use dollar assert and our statement follows. But when it comes to concurrent assertion, we use property. Uh, we use property and end property. Inside that, we give some temporary behavior that when that statement should be uh, asserted, like that we give some conditions, and then we take that property name and we assert that property name. And this dollar assert will not work repeatedly. It will work only once. But when it comes to concurrent assertion, it will keep on repeating based on our condition.
Okay. So while we are doing randomization, obj.randomize before you have written, right? So
Okay.
sometimes we use if else. If randomization is successful, then print some statement else. Okay. Sometimes we use assert also. So what is
Yeah.
the difference between both?
Actually, assert and if else, these both are similar in functions. I too used that instead of if else, I too assert, because assert also do that same function, especially this immediate assertion.
Okay. Okay. Fine. So in UVM, can you tell me what are the different type of phases and what is the difference between task-based phases and function-based phases?
Okay.
What are
Uh,
task-based
we,
and function-based?
when it comes to phases, we have around 9 phases, like build phase, connect phase, and we have end of elaboration phase, and then we have run phase, and uh, we have 5 more phases. I can't remember that right now. But in that task phases, run phase is based on tasks, because a task is a time related one. So our run phase also consumes some time. So that run phase comes under that task based phases. Remaining all comes under function based phases. It will not consume time, zero time phases.
Okay, fine. So yeah, it's a good discussion with you. And in the next round, we will get more into the coding part in UVM
Okay.
and SystemVerilog. So you need to revise some concepts in SystemVerilog and UVM like virtual interface, how do we connect with the transaction class to DUT, and also you need to go through UVM phases concept and remaining all UVM concepts, configuration
Okay.
DB or reporting mechanism, whatever. And also in Verilog HDL also you are lagging in blocking and non-blocking assignments and reminding how to create the final state missions in Verilog. Okay, so go through those and we'll get back to you. Okay.
Okay.
Yeah. Okay. Thank you.
Yes. Thank you.